What's up, everyone? Vin here, and welcome to the May 2025 live stream for AP Calculus AB and BC. So, yeah, I'm going to get moving here. I did put the questions I'm going to go over in the description. I can already see in the chat, will there be a polar FRQ? So the BC stuff I'm going to do towards the end so that, AB is going to cover stuff that'll be on both exams. But I do have some BC stuff for the end. And, if we want to see a certain polar FRQ, what I'll probably wind up doing is I'll do another night of live streaming tomorrow, and I'll just do FRQs tomorrow because I was going to try to do it all at once tonight, but I think doing it all in one shot might be a little bit much. So there will be a polar FRQ, but I could put that in the mix for tomorrow. Okay. Otherwise, in the meantime, I did do a live stream last year where I did a day of just FRQs, and I'm pretty sure I did go over a polar one. Okay. How long will the stream be tonight? I'm going to get through 50 something multiple choice questions. So FRQs, as of now, I'll see how I feel at the end. Maybe I could throw one in as like a bonus question, but I was leaning more towards doing FRQs tomorrow night. Because I could just do maybe, 1-2 hour live stream so that I'm not up too late, because I do want people to go to sleep and get a, decent night's sleep before the test. Okay. So I guess I'll just get rolling here, and just thank you to everybody who's on with us right now and ready to roll. So let me get my writing tablet plugged in because the wireless seems to have kicked off. So let me just get this up and going here. All right, here we go. All right. So the first question is just fundamental theorem of calculus. So here we should know the power rule for antiderivatives. So this one is like, if we don't have this one, it's going to be kind of rough at the AP test. Just make sure that you have this and you're using this when n is not equal to -1. If n is -1, then you're going natural log. So here I look at this and I just go, I'll write it over here. This will be x to the -3 plus 1 is -2. And then we divide by -2. And we're going from 1 to 2. Okay. And from here, what I like to do is the constant attached by multiplication is -1/2. And then I like to plug in the upper lower limit to the parentheses here, but I like to leave the constant. See this piece over here? I leave this piece on the outside like this. So now just throw in the upper and lower limit. So we're going to have 2 to the -2 minus 1 to the -2. And now this will make -1/2 times 2 to the -2 is 1/2 squared. And then this is just going to give us -1. So now we've got -1/2 times 1/4 minus 1. Okay. So now from here, we just simplify. Oh, Ben, hello. So shout out, of course, to my, my students, period 1, 2. I hope you're all doing well. So now we just simplify here. We've got -1/2 times 1/4 minus 1 is -3/4. And then just multiply. That's going to give you 3/8. Okay, so choice D should be our answer here. Okay, so knowing how to do this no calculator stuff is very important. So just make sure you're good. All right, a nice higher order derivative question. So fourth derivative of f. So this is just like kind of warming up with the techniques, and then we'll get into the big ideas. But you should be able to do a chain rule here. When you're deriving something, I'll write it in terms of g of x. G of x to the n. You're going to do n times g of x to the n minus 1, but then you multiply by the derivative of the inside here. Okay, so derivative of the outside, keep the inside the same, times the derivative of the inside. So we go power rule first, and now to the power 3, but don't forget chain rule. Okay, make sure you're deriving the inside. The derivative of 2x plus 1 is 2. If you forget that, you can guarantee there's going to be an answer choice waiting for you. Okay, so and Adrian Crane might be cooked. I hope you're the one that does the cooking on Monday. All right, just learn what you can from now till then. I know it's normal to be anxious. I would be anxious too if I had to take that test. I'm anxious for, my students and then my YouTube people as well. But where do I get the practice FRQ questions from? So at Troy, I'll send you a link in the chat. If you just Google AP Calculus AB free response, you'll get a set of AB questions. So here, just copy and paste. Yeah, this is the best. Yeah, I mean, so at Psychics, these are questions from like old exams. So the questions on the AP tests are going to be ranging from like okay to sort of difficult to like, whoa, crazy difficult. So, yeah. Some of them here, like will be simple. Some will be not as simple. So, all right. So chain rule here. Derivative of the outside, keep the inside times derivative of the inside. And now we just repeat the process. So 3 comes down to multiply to make 24. 2x plus 1 to the second. But then times another 2, which is 48 times 2x plus 1 to the first power. Okay, wait a minute. I think we got a little carried away here. 1 second. Let's see. Where are we? Oh, wait, no, second. Yeah, second derivative. Yeah, 48 times 2x plus 1 squared. Okay, yeah, that's the piece. Just had to make sure I was transferring it. So what I was doing here, 24 times 2 is 48. 2x plus 1 to the second. So now third derivative. So third derivative, 2 comes down to multiply to make 96. 2x plus 1 to the first times another 2. So now that makes 192 times 2x plus 1. And then finally, the fourth derivative, don't put 4 apostrophes, especially BC people. Make sure that you write it like this. So parentheses 4 and then parentheses x. And that'll just be 192 times 2, which gives you 384. So the fourth derivative is constant. So the fourth derivative at 0 is just 384. Okay, so yeah, that'll be that. Yeah, have fun on the AP exam. I hope you all do okay. Do you know what the typical curve out of 100 for a 5? All right, for a 5, this is not set in stone what I'm about to write, but for a 5 out of 108, okay, I would say you need like, if you get like 70 to 75, like that'll go to a 5. I've seen it as low as like 64. Okay, so the low I've seen was like 64 going to a 5. I guess if they make the test really difficult, then they mark it lower. But yeah, so 64 out of 108. But sometimes like 70 to 75 depends. All right, so next up here, this one we could do quotient rule or we could do chain rule. How about we practice quotient rule? So u over v prime is vu prime minus uv prime over v squared. So this will have u here and v here. So now dy dx is equal to 4 plus x squared times 0, and then minus, we're going to have 3 times the derivative of the bottom is 2x over the bottom squared. And now this part cancels, and we get negative 6x over 4 plus x squared squared. Okay, so this works out to choice A. Alternatively, like what you could do is you could say y equals 3 times 4 plus x squared to the negative first, and you could use the chain rule. So you could go dy dx equals negative 1 comes down to make negative 3, 4 plus x squared to the negative 2, and now the derivative of the inside is 2x. And you see how you get negative 6x times 4 plus x squared to the negative 2, which is the same exact thing as this in red. So, all right, what's my advice? Someone who still has weak points on the FRQs and the MCQ calculator section. So for the FRQs, you have time until the AP test to pick like your worst type of FRQ and just try to get really good at it. Like for sure, the one I would say you could guarantee to expect is like rate in, rate out. That FRQ is there basically every year. So like know how to do this. And graph of f prime or like graph of a derivative. And then they start asking you like local extreme values, points of inflection. Like these two, make sure you know them inside out. If it's differential equations, make sure you know how to solve a differential equation with separation of variables, because that's worth like 5 points. So being really good at these three will like do tremendous things for your score. If you're not good at the calculator MCQs, then yeah, I would just, what's it called? Like practice what you can from now to then. All right. So moving on. And let's see. So next we've got the derivative dy dx is cosine 2x. What is y equal to? So for this one, these are some nice little formulas to know. When you have cosine of kx, the antiderivative is 1 over k sine kx plus c. Okay, this is a nice quick antiderivative to know. So here, if you're going from like dy dx to y equals, you just anti-derive. If you want to treat this like a differential equation, just to get, warmed up for unit 7, you could call this cosine 2x over 1, cross multiply, and you got dy equals cosine 2x dx. And now just anti-derive both sides. The antiderivative of 1 with respect to y is just y equals, and now here's the formula, the one I'm writing over here. You could just say 1/2 sine 2x and then plus c. Okay, so 1/2 sine 2x plus c looks like choice C here. All right, cool. Yeah, definition of an integral with the summation formula. I'll try to find a question on that for sure. Yeah, that one's a little wacky. So let's see. For this one, limit as n goes to infinity. So when you're finding limits at infinity for rational functions, just focus on the leading terms. Okay, so this, I'll show the in-between step. I don't have to do this. Like this goes on in my head, but the math I'm doing is I'm only focusing on the leading terms. And then n squared over n squared cancels, and the limit is equal to 4. Okay, so that's it. That's really all there is to it. It's really not that bad. So that's that. Yeah, this question's a little light here. Yeah, the running joke is if you don't know the derivative of x by the AP test, that's your score. Okay, so f prime of x is equal to 1. And then f prime of 5 is equal to 1. Okay, so these are just little warm-up questions to get us rolling here. And now we'll take a look at some of the other stuff. So here, which of the following is equal to natural log 4? Well, this, people might think, ooh, do 3 plus 1 is 4, but not this. This would be equal to natural log of 3 times 1, which would just be equal to natural log of 3. Okay, so this one's out. Same thing here. You're not going to just divide those two. That would only work if you had like natural log 8 minus natural log 2. Then you'd have natural log of 8 over 2, which would be equal to natural log 4, but that's not what's happening here. So this one's out. So now we get into unit 6. The antiderivative of e to the t is e to the t from 1 to 4. So we have e to the 4th minus e to the 1st, which is not equal to natural log 4, so this is out. This one is a BC only, so it kind of doesn't belong here, but I'll show it anyway. But it's going to be choice E. Reason being, the antiderivative of 1 over t is natural log absolute value t from 1 to 4. And then you have natural log absolute value 4 is 4 minus natural log of 1 is 0. And this equals ln 4. Okay, so that's why it's this one. Choice D, though, this is for the BC only people. For BC, the antiderivative, I'll just show the antiderivative of ln. And for this, I would use integration by parts. So this would be like u dv. I would say u equals ln x, dv is equal to dx, and then du is 1 over x dx, v is equal to x. And you just go the antiderivative, I'll write over here, equals x ln x, but then minus the antiderivative of x times 1 over x dx. Now x over x cancels, so we get x ln x minus the antiderivative of 1 is x plus c. Okay, so if we had to, we would go x ln x minus x from 1 to 4. And then this would give us, we'd have 4 ln 4 minus 4, but then we'd have minus 1 ln 1 is 0, because natural log of 1 is 0, like this. But see how this does not work out to natural log 4, because we get minus 4 and then plus 1, which, yeah. And also 4 ln 4 is no good, so this one is off. So definitely choice E. Oh, hello to Troy. I appreciate the shout out. And oh, my own students. Yeah, geometry. You're gonna do a mock Regents. So, but I'm glad you all stopped by to say hello. If you want to just stay and listen to a calculus live stream, by all means, everyone's welcome, not just people in calculus. Do most AB teachers? All right, so at Animal, this was like questions from like a 1985 test. So in 1985, they used to teach integration by parts in AB. So most no. So that's why I said, hey, BC only. So everyone else just kind of ignore what I said. Oh, and I'm not sponsored by Izzy, but I do enjoy these drinks. I feel like I should have reached out to them for a sponsorship. I did get a haircut. It was time. It was absolutely time for the live stream. You know why? If my hair gets too crazy, then it's hard for me to green screen and key out my hair if it's all frizzy. So yeah. Cooked for the mock Regents. No, it's a classwork grade. You'll be okay. All right, but back to calculus. So the slope of the line tangent to the graph of y equals ln x over 2 at x equals 4 is. So this just tells us to take the derivative. Okay, so we take the derivative. So y prime, you could know this, the derivative of natural log of f of x. This is definitely going to show up. It's like 1 over f of x times f prime. But here I would have 1 over x over 2, and then times the derivative of the inside is 1/2. Okay, so this is a little bit complicated. Then we get, 1/2 over x over 2, and this becomes 1/2 times 2 over x. So the derivative is just 1 over x. But at x equals 4, see y prime is equal to 1 over x. Y prime at x equals 4 would be 1/4. Okay, so choice B. 8 is choice B. Now an easier way. Ready? Something easier. So the easy way to do this is to take y equals ln. I'm going to call it this, 1/2 times x. Log properties. This is natural log of 1/2 plus natural log of x. You could split multiplication up with addition with logs. So then y prime equals the derivative of a constant is 0 plus the derivative of natural log x is 1 over x. You see how you get the same exact derivative here? Okay, and then you just plug in and you're done. So I like that one. I like that one. Like, that's like an easier way. Oh, at Tweakers. Yeah, that's fine. It's okay. You could just nod and pretend you understand. Oh, your teacher probably taught it because she took AB in the dinosaur age. Yeah, see, I want to laugh at those jokes. Like, haha, like people are old, but like I'm getting old too. So it's like less funny. But good for you for like being, in your teen years and stuff. So, enjoy your youth. Okay. So this one, the integral from -1 to 1 of e to the negative x squared equals k. Then what is this? So this one here has to do with even odd functions. So e to the negative x squared is even, which means it has symmetry over the y-axis. So it would look something kind of like this. Okay, so let me draw that a little better. It's kind of like the bell curve in a way. Looks something like that. All right, not my best artwork, but you get the idea. So from -1 to +1, we have to know the definite integral is the area under the curve. And I should say the signed area. So if we're above the x-axis, the area is positive, and if we're under, the area is negative. So here, see how like this piece over here, like on the left side, is equal to this piece on the right side. So, I mean, I don't know. Let me say I pick like W and W. So I could say, you know, actually, you know what? I'll just, hopefully this part will just make sense. If the integral from -1 to 1 is equal to K, then from -1 to 0, this space would be half. So we would just do K divided by 2. Okay, so choice D. So this one is just seeing the symmetry of an even function. And that idea will show up later for odd functions. When you have an odd function, like let's say x to the third power, then you have something like this. Okay, and if I had area like this, let's say I was looking at the integral from like, I don't know, -2 to 2 of x to the third. Without doing any thinking, I just know it's 0 because the area is equal but opposite. So it just works out to 0. The test should be, what's it called? On the computer, but your free response you write on paper. Calculator is allowed for part of it. Okay, here we go. Some implicit differentiation. So y equals this, then dy dx equals whatever. So for this one, realistically, you might forget this formula. The derivative, let's say you don't know, let me write this out. The derivative of a to the f of x equals a to the f of x, natural log a, and then times f prime of x. If you can memorize this, then you're done very, very quickly here. Okay, but if you can't memorize that, then there's going to be a backup way to do this. So I could say, let's say I use the formula. dy dx is 10 to the x squared minus 1 times natural log of the base times the derivative of the exponent. So I'm just looking for 2x, natural log 10, 10 to the power, and this one is looking like choice D. Okay, so let me just make sure that we're good, and we are. Choice D is it. But this is the, I forgot the formula. So like, I forgot the formula. Then how do I do this? So if you forgot the formula, you're going to take y equals 10 to the x squared minus 1, and you're going to natural log both sides. Okay, so natural log both sides, you get natural log y equals the power x squared minus 1 could come down like this, and then you got natural log 10 here. And now what we have, we've got, let's see, the derivative of, we've got 1 over y prime equals, the derivative of x squared minus 1 is 2x. Natural log 10 is a constant, so it just tags along for the ride. So 10 is an A-B question. Yeah, it's just derivative of an exponential function. So this is A-B friendly as well. So I can just multiply both sides by y, and you see how I get y prime equals 2x times natural log 10 times y, but y is equal to 10 to the x squared minus 1. Okay, so same answer. I didn't use base 10 because the answers all have natural logs in them. Okay, so if I could do this any way I wanted, then yes, you could technically use log 10, but usually we like to work with natural log because that derivative is easier to work with. Okay, so, so at Psychics, the BC questions are going to be at the end. Everything is AB until the very end. Okay, so after like question 45, around 45 is when I go BC. So AB basically the whole way. All right, cool. So also AB coming up. All right, a position of a particle is moving, the position of a particle moving along a straight line at any time t is given by this. So here's our position function. And what is the acceleration when t is equal to 4. So we have to know position. You take the derivative with respect to time. Let me just fix that. So derivative gives you velocity. Take another derivative, and that gives you acceleration. Okay, so the velocity function, we just do the power rule, is going to be 2t plus 4. Okay, and then next we have the acceleration is equal to 2. So we're just doing the power rule twice. So what is the acceleration at t equals 4? Well, the acceleration is constant here, so it's just equal to 2. All right, so 11 should be choice B. All right, so that is the end of that one. So now next, yeah, so conceptual questions are coming up at Christina. They're, technique, and then concepts will be for sure showing up, a little bit later. All right. But I could also mention concepts as we go. But we have like graph of f prime questions and all that. Okay. How close are... Oh, to the actual... I mean, these are actual questions from old exams. So, like, questions like this are definitely fair game. Okay, so here, a substitution u equals x over 2 is made. Then which integral do we come up with here? So, if u is equal to x over 2... then we just derive both sides. So we could say du. See how like I'm just basically doing the derivative with respect to x. So I basically get du. I'll even write it like this. Du dx is equal to the derivative of x over 2 is 1/2. Okay, so let me just clean that part up over here. So this is equal to 1/2, which tells us that du is equal to 1/2 dx. And what I'm going to have to do is I'm going to have to make a substitution for dx. So I can multiply both sides by 2, and I can say 2 du equals dx. So I have this. And I also am going to find new limits of integration. So the new limits, see how these are the old x equals limits, x equals 4 and x equals 2. So I'm going to write u equals x equals 4. I'm plugging in x equals 4, but dividing by 2 to get this. And then my new lower limit be u equals x equals 2 divided by 2, which gives us 1. So finally, we can make the new integral here. We could say the new integral is going to go from 1 to 2. It's going to be 1 minus, and we're going to have u squared over x, and then dx is 2 du. Now, this is where some students are like, oh no, like the math isn't fair. And they're like, how do I deal with that x? But all you got to do from this step, if u equals x over 2, you could say 2 times u is equal to x. So we could replace x with 2u. See, and then 2 over 2 cancels. So the final integral here for this question, we have the integral from 1 to 2, 1 minus u squared over u, and then du. Okay, so this would be what we're looking for. So that's looking like choice A. 1 minus u squared over u, du, integral 1 to 2. Okay, so this one, I mean, it's like borderline conceptual. I mean, this is probably more technique because like we're not actually finding the actual value of the integral. We just have to know the ideas. All right, so, oh, they said now would be a good time to insert ads. I don't, personally, I don't want to put ads on my live streams because I want you all to get the full continuous experience. So, do I think there's going to be a polar FRQ? I think so. But it's hard to make the predictions because like maybe they're just like kind of like quietly phasing out polar FRQs, but it's been parametric FRQ for like years and years. So, yeah. But they're definitely due for a polar question. All right, so more technique coming up. So we want to know the derivative here. We have this equation. So we're doing derivative with respect to x of this. So the derivative of x squared is 2x plus, now we do product rule. The derivative of x is 1 times y plus x times the derivative of y is dy dx. Plus, and now just so you know the concept, when you're deriving y to the third with respect to x. What we're really going to do eventually is the derivative with respect to y of y to the third. But you can't just swap out x and y and hope no one notices. That's why we have to multiply by dy dx to balance things. Because you can see dy over dy would cancel, bringing you right back. So we have to use the chain rule here. Okay, that's what's going on when you do implicit differentiation. So you get plus 3y squared dy dx and now equals 0. And now we have to keep these terms together. The dy dx terms belong together. So now I'm going to go minus 2x on both sides and also minus y. So these terms wipe out. And now I could factor this out. I'll write it over here. We've got dy dx times x plus 3y squared equals negative 2x minus y. And then to solve, we just divide both sides by x plus 3y squared. And our derivative implicitly equals, and we get here, and then I notice like, oh no, none of my answers match. And that's because we could take the negative out on top and write 2x plus y over x plus 3y squared. And this negative could stay in the numerator, or we could write it in front like they do in choice A. So for 13, we should be getting choice A. And it is. Cool. All right. So velocity of a particle on a line. Sorry, this thing just decided to zoom. All right, so here we go. But the velocity of a particle moving on a line at time t is given by this equation. How many meters did the particle travel from t equals 0 to t equals 4? So for this one, we should know sort of like domain and range ideas. But I think of like square root of x just looks like this. Okay, it's going up like that. T to the 3/2 power. So I take the square root of something raised to the third, but I'm between 0 and 4. I know like this is also like, you know, positive on 0, 4. And this one is also positive on 0, 4. So the idea is when you're finding like how many meters did the particle travel, that's distance. So the distance is integral a to b, absolute value of velocity. But I want to point out here that on 0, 4, so on 0, 4, the absolute value of v is equal to v because these are both positive. Or I should say like positive, like they're greater than or equal to 0. Positive or 0. Positive or 0 on this interval here. Okay, so that's just kind of like what's happening in the question. Okay, displacement will equal the value for, like the value for displacement, like the magnitude, will equal distance as long as velocity is, you know, positive. As long as your like particle is just moving to the right or moving up. So just want to point that out before I just assume like, hey, I could just integrate velocity. Because technically, like this is distance. And the difference is like when I have just integral a to b of velocity, this one is displacement, which is a slightly, you know, it's a different concept. I can't even say slightly different because it like the numbers could be way different. All right, so now let's go ahead and find it. So we've got 3t to the half plus 5t to the 3/2 dt from 0 to 4. And now this is, we have 3t to the 1/2 plus 1 gives us 3/2. And then we multiply by the reciprocal 2 over 3. Plus 5, I'll leave a space, t to the 5/2, and then multiply by the reciprocal 2 over 5. And we're going from 0 to 4. So now 3 over 3 cancels, 5 over 5 cancels, and we just plug in. And we're plugging in 0 at the end, which is nice because that'll wipe everything out. So we're going to have 2 times t to the 3/2 power. So t is 4, and we're raising this to the 3/2 power. And then plus, we got 2 times, and we're plugging in 4 to the 5/2 power. And then minus 0 at the end because we're going to plug in 0, which would wipe everything out. So this is going to give us 4 to the 3/2 without a calculator. I would do the square root of 4 first and then cube it, which gives us 8. 2 to the third power is 8. And then what we have next, when we have 4 to the 5 halves, same idea, square root of 4, but then to the 5th power, 2 to the 5th power is 32. Okay, so now we just work this out. We're going to have 2 times 8 plus 2 times 32. And this gives us 16 plus 64, which gives us 80. Okay, so this one should work out to 80, choice D. Okay, so yeah, this one, like, had a little concept to it. Like, make sure you know all that stuff here. Oh, wow, we got 100 people here. I appreciate you all being here. I can't say that enough. It means a lot to me, especially, you know, on a Saturday too. This isn't even the night before the test, and, you know, such a cool turnout already, you know, having people stop by. So thank you for the support. And if you haven't subscribed yet, that would I would really appreciate it. Trying to get my sub count up. I'm at 40,000, almost 41,000, but it's been a fun ride seeing this, you know, move along. All right. So velocity, blah, 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 moving along the x. Here's our velocity function. At t equals 0, position is 4. Then at any time t, x of t is. So this is like kind of like unit 7. All right, so here we should know that we go from position to velocity to acceleration. And for this one, we would derive to go this way. So if I want to go from velocity to position backwards, I would anti-derive. Okay, so we're going to do the anti-derivative when we want to go backwards. So that's the idea. So that's what we're going to do first. We're going to do the integral of velocity. So the integral of 2t minus 4 like this. And this is going to be, we have the antiderivative of 2t is t squared, because I get 2t squared over 2. And then minus 4t plus c. Okay, so this is our position, you know, our position function here. So they told us at t equals 0, position is 4. So that means x of 0 is 4. So I could say x of 0 equals 0 squared minus 4 times 0 plus c. And this is going to equal 4. So this tells us the constant is equal to 4. So then x of t is just t squared minus 4t plus 4. Okay, t squared minus 4t plus 4 is looking like choice C here. Okay, just making sure I'm not missing anything crazy here. Okay. All right. I mean, if you plug in 0, you should get 4. That wipes out this answer choice, this one, because you get negative 4, and it wipes out this one. And you narrow down your guess to 50-50. Okay, so process of elimination is pretty cool too. All right, relative maximum. How do we find a relative max or min? So the first derivative test. So we derive. So we have 3x squared, and then we have minus 6x. We set the derivative equal to 0. And then from here, we would have 3x times x minus 2 is equal to 0, which gives us roots at x equals 0. Wait, did I say something crazy before? Negative 4 times 0. What did I say? Yeah, negative 4 times 0 is 0. But the plus c tells us c is equal to 4. Oh, hello, it's Sophia. Thank you for joining. Yeah, shout out to all period 1, 2. Thank you for joining. All right, our final class together, right? Or final 2 classes. All right. Oh, Aiden as well. Ben, I see you all. So let's see. X equals 0, and then we get x equals 2. Those are the roots. So then we throw these on the number line for f prime. So 0 and 2. A little trick. I look at f prime, and this is what I'm thinking. I'm like, all right, f prime is quadratic, and the roots are 0 and 2. So it would go like this. It goes positive, negative, positive. So that's how I know this is going to be plus, minus, plus. You know, if you want to plug in test values, like you could, of course, plug in like f prime negative 1. and you get like 3 times negative 1 squared minus 6 times negative 1. Like you could do this, but this takes a lot of time. Okay, and then 3 plus 6 equals 9. You're like, positives. You put a plus here. Okay, or you could even plug it into the factored form. Like once again, when you have f prime equals 3x times x minus 2, if I plug in something like 1, I get 3 times 1 times 1 minus 2. And I'm like, ooh, a positive times a negative is negative. Okay, so these are just all ideas that it helps to have. And now the behavior of f, if f prime is positive, f is going up. If f prime is negative, f is going down. And if f prime is positive, once again, f is increasing. So a relative maximum occurs when the first derivative changes from positive to negative. Okay, so that's why it's going to happen here at 0. So 16 should be choice B. All right, if they asked us, where is there a relative minimum, we would say at x equals 2. Okay, f would have a relative minimum at x equals 2. All right. So let's see it. John Doe, for implicit differentiation FRQ on the BC exam, will the question explicitly say you need to use it? No. You should just see that there's x's and y's, and then that gives it away that you have to use it. Okay. Oh, wait, this question's out of place. I'm sorry. This is BC only. But whatever. All right, so the people taking AB just, what's it called? Yeah, people taking AB, just tune me out for this part because it's going to be a BC question. So integration by parts, we have U, and we've got dV. Okay, so U is equal to X, and then dV is going to be equal to e to the negative X dx. Now, this one you're going to use at some point of the AP test. So we got 1 over K e to the kx plus c. All right, so that's what I'm going to be using here. Du is equal to 1 dx. But v, the antiderivative of e to the negative x, k here, see, like if I use this idea, it's like k is equal to negative 1. So 1 divided by negative 1 is negative 1 or just negative, and then I get e to the negative x, like that. So now I apply integration by parts. So I'll write that over here. So integration by parts, here it comes. We're going to have, next up here, we've got u times v. So we have negative x e to the negative x, evaluated from 0 to 1. And then we have minus the integral of v du. Okay, so if I do minus, like v du is negative, so I have a minus minus, this is going to change to a plus. And now I have e to the negative x dx. Okay, so for this question here, like this is what's happening. And now we anti-derive this. So this I'll leave unsimplified for now. And the antiderivative of e to the negative x is minus e to the minus x. And we're going from 0 to 1. So now I just plug in and simplify carefully. So I plug in 1 first. So we're going to have negative 1 e to the negative 1. And then minus, I plug in 0. But when I plug in 0, see how there's an x in front? That's just going to make 0. And now we have minus, and I'm going to put parentheses for this part because I'm going to simplify this and then distribute the negative after. So we have minus e to the, we have minus 1, like this, and then minus e to the 0 power. And this gives us, we have negative 1 e to the negative 1, but then we have minus another 1 e to the negative 1. And then e to the 0 is 1, so we get minus minus 1 becomes plus 1. So this becomes 1, and then minus 1 is minus 2 e to the negative 1. And that matches up with choice C. So a nice little integration by parts question. Yeah, you could bring a mouse, as long as it's not like a ChatGPT mouse or something. Okay, cool. So this one, y equals cosine. All right, this question I'm just going to say, this one's a little outdated. Not like crazy outdated, but for this one, the thing to know, it's a sneaky formula, is that sine 2x So yeah, in the 1980s, the questions, like, kids had to know trig identities. So it's like a little outdated. So at the end, we're going to be like, hey, where's my answer? And like, this is how you find it. This is going to be based on this. So chain rule here. How I imagine this, when I hear cosine squared x, in my head, I think of cosine x in parentheses squared. Okay, so when we find the derivative, or I'll say y prime, not dy dx, because they're saying y prime, equals, so I do the derivative of the outside first. I go 2 times cosine x to the first, but then times the derivative of cosine is negative sine. And then minus, now I'm thinking about sine of x in parentheses squared. So I power rule, I get 2 times sine x to the first, times the derivative of sine is cosine. So this gives us y prime equals, we have negative 2 sine cosine minus 2 sine cosine is negative 4 sine x cosine x. Which, you see the relationship here? If sine 2x equals this, I could just multiply both sides by 2, and that tells me 2 sine 2x is equal to 4 sine x cosine x. So you see how we have like 4 sine x cosine x here? So that's the same thing. I've just put a minus. This is minus 2 sine 2x. Okay, see, like I could just put a negative here and a negative here, and then just replace. Okay, so this one, 18 actually works out to choice C. But this one, like I said, outdated. But this is not outdated. Knowing the chain rule is not. Okay, cool. All right. Oh, here we go. Concepts. Yes, there will be a recording of this. So this will go, in my channel in the live section. I should, for a moment, to self-promote my old stuff. But my live streams last year, I would say, still stand the test of time. I did 50 multiple choice questions on day 1 for units 1 through 5, 50 multiple choice questions for units 6 through 10 on day 2, then 8 FRQs on day 3, and then day 4 was just a bunch of mixed. All right. Cool. So this one, if f is a function such that this is true, which of the following must be true? So for this one, you got to know, I'll say this. I'll just say, you know what? Let me write it like this. I'll just say f prime of a equals the limit as x approaches a of f of x minus f of a over x minus a. So this means, if this limit exists, we could say f is differentiable at x equals a. Okay, and f prime of a equals whatever that limit is. So here, if this is the case here, what I do for these kinds of questions is I translate this to this language. So you all see that if I just erase the letter A and I replace it with 2, then it's going to build the expression up here. Okay, so I'm going to get rid of this. Say 2, and then one more time. Say 2. So if this is all equal to 0, over here, what does this tell us? It tells us f prime of 2 is equal to 0. And that would say the derivative of f at x equals 2 is 0. Choice C. Now, why are the other answer choices no good? The limit of f as x approaches 2 does not exist. That can't be true. So the concept, once we know f is differentiable, in this case at x equals 2, this implies that f is continuous at x equals 2. Differentiability implies continuity. So f is continuous at 2, and that would imply that the limit exists at x equals 2. And the function is defined there too. Okay, so since f is continuous at 2, the limit exists and f is defined. All right, f is not continuous at 0. I'm sorry, f is continuous at 0. It doesn't have to be true because this is all happening in the neighborhood of 2. So 0 is like a different neighborhood, so who knows what's happening there. And then the function value at 2 equals 0 doesn't need to be true. The derivative at 2 needs to be 0, but not the function value. Okay, cool. So concepts, more technique. All right. So here, y equals arctan cosine x. The derivative is, so just know the derivative of arctan of a function is 1 over 1 plus function squared times f prime of x. Okay, so here, when I use that idea, it's like saying here that the function f of x is cosine. So dy dx is equal to f prime would be negative sine x. Now we're over 1 plus that inside function squared. So 1 over 1 plus cosine x squared. And 20 is looking like choice A. All right, so choice A it is. You, depending on your school, you'll get a calculator. I know my school provides them. You get the option of, doing Desmos or the calculator. But I would just go by, I feel like most schools have to provide it, but I'm not going to say every school will. I don't know what everyone's budget is. So the school I work at, does that for the students. All right, so integral of piecewise functions. So this one, it helps to know this antiderivative is 1 over k sine kx plus c if we're indefinite, but here we're definite. So for this one, the idea is and I'll say not drawn well to scale, but x plus 1 looks like this, but I'm going to stop it at 0. Okay, so I'm going to put this kind of open circle here. But then cosine of 0 is 1. So this one picks up where the other one left off, and it starts doing this stuff. Okay, so we're finding the integral from negative 1 to 1. This is the red when x is greater than or equal to 0. And then this is the purple. Let me make this purple when x is less than 0. All right, so I'm going to say here, this is the integral from negative 1 to 0 of f plus, and I'll change colors, the integral from 0 to 1 of f of x dx. But it's piecewise, so I'm only going to go with the red for the greater than 0 part and purple for the less than 0 part. So here, we'll say this is equal to the purple integral negative 1 to 0 of x plus 1, and then plus, we've got integral 0 to 1 of cosine pi x. All right, this one, honestly, I probably would rather use geometry. From negative 1 to 0 is the area of this triangle. And you see how this would go over 1, up 1? So I could do the area of that piece is just 1 times 1 divided by 2. So this is equal to a half. If you're more confident using fundamental theorem of calculus, you could also just go, all right, 1/2 x squared plus x, you just anti-derive this, and you evaluate it, negative 1 to 0 like this. And that's going to give you 0 minus 1/2 times negative 1 squared is going to give you just 1/2. And then we get minus 1. And that gives us 0 minus negative half, which gives us positive half. But finding the area of that little right triangle here, it's debate. I don't know. It's up to you to decide which one you think is easier. They're both around the same level. So now plus, using this anti-derive, we got 1 over pi sine pi x, and from 0 to 1. And this one, I think we're spared a bit here. This is 1/2 plus 1 over pi. And then we get sine of pi times 1 is pi. I'm just going to say here minus sine of 0. Sine of pi is 0 and sine of 0 is 0. So this works out to a half. One thing I want to point out too, the calculators, you should know how to navigate one of these things that, if I had to, let's say this is a no calculator question, but for the calculator section, you should know math 9 and then 0 to 1 and then cosine of pi x. Second up x. Make sure you're in radians when you're typing in trig functions. You see how that just works out to 0. Okay, so that's why it's 1/2 plus 0, or just 1/2. Cool, so choice D. All right, moving on. So for this one, whoops, sorry about the scrolling here. Let's get back. So this one, the theme is algebra before calculus. So here I would go integral 1 to 2, x plus 1, x minus 1, over x plus 1. And now the factors cancel. And this is integral 1 to 2. One thing I should point out also, this technically has a whole at x equals -1. But that's not an issue. A removable discontinuity is not an issue when you're integrating. You could kind of just like integrate right through it. If you have a vertical asymptote, then that's like Calc BC territory with improper integrals. 52 or 3, somewhere around there. Yeah. So quite a few I'm going to go through. Yeah, 50-something questions. All right, so now here we simplify. We got 1/2 x squared minus x from 1 to 2. And that gives us 1/2 2 squared minus 2. But then minus, I plug in 1. And when I plug in 1, I get 1/2 minus 1. So this is half of, I got to do math. So half of 4 is 2 minus 2 cancels. But then minus 1/2 minus 1 is -1/2. So 1/2 yet again. It's a popular number today. It is 1/2. Cool. All right. Concept. All right, concept coming up. All right, because I know someone's like, hey, where's the concept questions? They're like more later. They're going to get like more challenging. So at Gene, live stream tomorrow. I'll see. I'm gonna, you know what? I'll try to throw together some like, maybe I'll throw together like, 5 FRQs and see if I could fly through them. I'll try to find some old ones so there's like a greater chance you haven't done them. But yeah, maybe I could throw some last minute thing together. Wow, 650 people stopped by. Thank you all. And for the 130 of you that are here, if you're not subscribed and you want to support the channel, please click that subscribe button and let's, get to the next level. But thank you. I appreciate you all being a part of this. This is like a very exciting time of year. This is like probably like my favorite time of year to be a YouTuber, just for the live streaming and being able to talk with all of you. So, all right, let's get to it. So derivative of x to the -3. So first you should write this in power form so that you could do the power rule. Okay, so now this is, let's see, you got -3x to the -4. And then -1 comes down to make plus x to the -2. And then plus 2x. And now at x equals -1. So this, I'm on the lookout for odd powers. Like even powers, no sign change. This is like -3 over -1 to the +4. Because see how this is like -3 over x to the 4 plus 1 over x squared plus 2x. So I'm plugging into this version here. So -3 over this plus 1 over -1 squared plus, oh, here we go. 2 times -1, there's the sign change. So this -1 to the 4th is just 1. This is 1. So we get -3. We get plus 1. And then we get -2. And that gives us -2 minus 2, which is -4. So choice B. Bro, I'm cooked. No. Just hang in there. It's normal to be anxious, but learn what you can from now to the end. 30 out of 45 multiple choice is pretty solid. Times 1.2 gives you a 36. Like you're already passing around that score. So like, yeah, 30 out of 45 is solid. All right, 28 out of 45. You're in a good position to do well on Monday. Oh, here we go, concepts. So where my head goes here is break this up. So -2 to 2 x to the 7 dx plus -2 to 2 k dx. Okay, you ready? X to the 7 is odd. So x to the 7 kind of looks like this. It just looks kind of like x to the third, but just steeper. So from -2 to 2, see how it's like equal and opposite? So this piece just goes to 0. Okay, and this whole thing is equal to 16. So what we get is basically like 0 plus, and now the antiderivative of k is kx from -2 to 2 equals 16. So over here, that becomes k times 2 minus -2 equals 16, and you get 4k equals 16, so k has to be equal to 4. So choice, uh-oh, the pen is possessed. What's going on here? All right, we're good. Choice D. And a 5 on the FRQs. Yeah, pretty good. Not bad, Aiden. Keep it up. On your way. Okay, so here, f of x equals e to the x. What is equal to f prime of e? So this, you could just L'Hopital all the answers, but the classic way is knowing this. Limit as h goes to 0 of f of x plus h minus f of x over h. So concept. Someone was like, concept. The concept, so that this is not just all formulas and techniques. This is like the idea of calculus. Let me draw that a little neater. So like, let's say this is f of x. Okay, and here's x, and then here is x plus h. Okay, so then when we look at f of x plus h minus f of x, this is like rise over run coming up. Okay, but the run would be x plus h minus x, which the gap between these two is equal to h. Okay, so that's what h represents, is the run. That's the run from x to x plus h. So when we find the slope between these two, it tells us the slope of the secant line. But if we take the limit as h goes to 0, what that does is it squeezes the points closer together. Okay, so we would have, like this goes here, let's say, and it moves like all this stuff with it. Okay, so as h goes to 0, the gap between these two shrink, and the slope of the line connecting those 2 points gets closer to the slope of the tangent line. Okay, so that's like why the formula works. That's the concept. But for here, if f of x is equal to e to the x, then we just run it through the formula. I could say that in this case here, that f of x plus h is equal to e to the x plus h. Okay, so I could just start building this up now. I could say, all right, f prime of x equals the limit as h goes to 0 of e to the x plus h minus f of x is e to the x over h. Okay, but then f prime of e, so the last thing here would be to plug in. I would have f prime of e equals the limit as h goes to 0 of e to the, I'm replacing x with e, so I'm going here like this. And you see how that makes e to the e plus h minus e to the e over h. Okay, so that one works out to, I'll just scan because my other paper is, so let's see, e to the e plus h minus e to the e over, it looks like that one. Okay, so choice E. Cool. All right, otherwise, when in doubt, L'Hopital. You could just L'Hopital every answer choice, but you're deriving, so derive with respect to h. Okay, and if you derive this, use L'Hopital, you derive the numerator and denominator, and you see how that gives you, if you're deriving with respect to h, it's going to give you e to the e plus h times 1 minus 0 over 1. And then as h goes to 0, that gives you e to the e, which is, if you derive this, f prime of x is e to the x. The derivative of e to the x is e to the x. So then f prime of e is e to the e. And you're like, hey, they match. So, but the formula is nice. The formula is good to know. Alrighty, trapezoid rule. I feel like this one is like borderline calculator though, because I don't know, we'll see. The numbers aren't so nice. So calculate the approximate area of the shaded region using the trapezoid rule, a division at 4/3, and 5/3. Okay, so this, let me zoom in a bit so we could see a little more. Not the best breakdown here. So this would be, if we break it down at 4/3 and 5/3, like just know if I start counting by thirds, like I have like 3/3, 4/3, 5/3, 6/3. See how like this is equal to 1, this is equal to 2. Okay, so we're just cutting this at 2 locations like this. All right, so we're going here. Let me do this in different colors. So we have like one trapezoid here like this. Then I have another trapezoid over here. And then I have a third trapezoid over here. Okay, so like that's the idea. What I'm going to do is I'm going to actually draw this separate so I could draw it like a little bit nicer, because this picture is like not the greatest. You got to feel bad for 1985. Like, I mean, in some ways, you know, maybe life was like easier, but I don't know. Like, that's like a hard picture to work with. Okay, so 2, and then we'll say 4/3. So I'm going to go 4/3 and 5/3. So what I do for this is I just make a little table. So X and Y, and we have 1, 4/3, 5/3, and 2. And then I plug into the function. I just square it. So 1 squared is equal to 1. If I square this one, I get 16/9. That's 5/3. I get 25/9. And this gives me 4. And then if I forget the formula for the trapezoid sum, what I do is I just write my y values above. So I have a y value of 1. Then I have a y value of 16/9. I have a y value here of 25/9. And then my last y value over here is equal to 4. Okay? And then what we do is we draw in our trapezoid. So like here's one trapezoid, a second one, and the third one. And a few things with the calculus questions involving trapezoids. For one, these type of trapezoids, they're looking sort of like this. The parallel sides are the bases. So this is like base 1, base 2, and the height would go this way. The area of a trapezoid from middle school is 1/2 height, base 1 plus base 2. But these are the ones that are parallel. Okay, so like that's the idea that I'm using here. So when I find this, the approximate area, I'm going to go, all right, 1/2. And from 1 to 4/3, see how this is a jump of 1/3 the whole way? So we have like 1/3. We're like counting by 1/3. So it's 1/2 times 1/3 times the sum of the two y values. We have 1 plus 16/9. Yeah, this one I'm going to use a calculator for, because this is like, I mean, I don't know. Maybe there's a way. If you want to practice the arithmetic, we can, but it just seems like kind of excessive. So plus 1/2 times the next one, same thing, 1/2 times a third. Delta x is the same the whole way through. And then we have 16/9 plus 25/9. And then plus 1/2 times 1/3. And we've got 25/9 plus 4. So this one, it's not like super worth. Let me see. Is this... I mean, I guess I could work this. All right, you know what? Whatever. We'll make our elementary school teachers proud. Let's do this together. Why not? Let's simplify this the old school way. Okay, so what I'm seeing is like this is 1/6. So I could go 1/6 times, and then I got 1 plus 16/9 plus 16/9 plus 25/9 plus 25/9, and then plus 4. So here I'm seeing like 32, like 50 plus 32 is 82. So we got 82/9 so far. And then we get 5. And 5, if I want to put it over 9, is the same thing as 45/9. So 1/6, and I have 45/9 plus 82/9. Okay. And now this is going to give us 127/9, but then times 1/6. And 127/54. Ooh, all right, that wasn't as bad as we thought. But someone fact checked me on that. This one, like, I added in after the fact because I threw away some really outdated questions and I replaced it. I mean, hey, I just did it without a calculator, so I think it's fair. But they usually make it nicer. I feel like that's just like unnecessary to do that. All right. Oh, concept. So this absolute value x looks like this. Okay, but the graph of absolute value x minus 1 moves this to the right one. So it goes like this. Okay, the turning point is at 1. And when we want the integral from 0 to 3, that's the area under the curve from here to here. So you see how we get two right triangles? So we're going to use geometry here. We're not actually going to anti-derive this. Okay, so this is like 1, 1, and a right angle. This one is from 1 to 3 is a jump of 2, and this is 2. And like if you're like, wait, how do you know it's 2? Well, if y equals absolute value x minus 1, when x equals 3, so make that neater, x equals 3, we get y equals absolute value 3 minus 1, which is 2. So that's how we know. So then this becomes, over here, we have area of a triangle. So area of a triangle is 1/2 base times height. So I would get 1/2 1 times 1 plus 1/2 2 times 2. And then I get a half plus half of 4 is 2. So I get 2.5. And that I could say, well, 1/2 plus 4 over 2 is 5 over 2. So it looks like choice D. All right, if you want to integrate it, it's like really like a mess. You kind of have to use like integration by parts. It's like one of those like challenge integrals. You know what? I'll tell you who to watch. Look up, shout out to this Epic Math Time. This guy has he still has a pretty great channel. He's been kind of quiet lately, but he's like a real high level dude who really got into like heavy theory at one point. Yeah, I mean, he hasn't posted a video in a while, but he did post something on integrating the absolute value of x. I believe it was him. Yeah. Black Pen, Red Pen, like also does it. I mean, if you are going to integrate it, like there's a few different ways. Like you would go, this is a piecewise function. So see, this is the line y equals x minus 1. And this is the opposite. This is like the line y equals minus x minus 1, like plus or minus. So that's the line y equals negative x plus 1. Okay, so here you would write this as a piecewise function. You'd have like negative x plus 1 when x is, let's say, less than or equal to 1. But when x is greater than 1, you would be on the line y equals x minus 1. So you would integrate this as a piecewise function. But this guy, on his channel, he made like a kind of like a joke. He's like, no, don't do piecewise. And he did some like high-level sorcery to land at that antiderivative. So I have pretty good long-term memory. But yeah, like that guy's, I mean, I'm a math nerd, so I enjoyed his videos. Like they were, like, you know, he did some like real technical stuff. And yeah, so if you are going to do it without geometry, the most user-friendly way is probably the piecewise stuff. But this is like entertainment. Okay, so next up, we've got the position of a particle. So I'll just say here like position, or maybe I'll use x of t because it's on the x-axis. How do I know it's 3, 2? Wait, how do I know? Oh, at that, because if I plug in to the equation, like see how this is like our function f of x. If I plug in x equals 3, I get y equals absolute value 3 minus 1. And that gives us absolute value of 2, which is equal to 2. Okay, so you could always plug an x value in to find the corresponding y value. So sometimes that helps. Oh, so at QWX, do I have anything on series MCQ? Yes. I have practice test for, if you just look up this, Look up like AP Calculus Unit 10 practice test. If you look that up on YouTube, like just click on my video for Unit 10. I have a PDF that I share and I do a walkthrough of just Unit 10 questions. Okay, so that's like a pretty solid resource that I think would help. So, all right. So moving on here. Let's see how we're doing. Oh, my computer isn't too hot. Yeah, I'm just making sure my Mac is not overheating. I have a Mac Mini from before the M series, but it held on pretty strong. All right, so here we've got this. All right, so concept. Average velocity. So a few things we need to know. The average rate of change of F on AB is F of B minus F of A over B minus A. Okay, so this is just something we need to know. Average rate of change of F of X. But another concept for this is that velocity is the rate of change of position. Okay, so I'll just write it out, of position. So we need to combine these ideas. Okay, what I mean by that is they're not telling us outright, like, hey, find the average rate of change of this. They're asking, like, they're telling you this is position, and they're saying find the average velocity. But velocity is the rate of change of position. So what they're really asking us for, when they're asking us for average velocity, they're asking us not only for average velocity, they're asking us for the average rate of change of position. Okay, so all we have to do here is x of 3 minus x of 0. Make this neater. So minus x of 0 over 3 minus 0. Okay? So, oh, I'm streaming. So, yeah. I wasn't streaming. Yeah, no, I decided to stream this year. I'm going to, do my best to do it every year. But I know, hopefully life doesn't get in the way, and I'll just be able to do these as long as possible. The honest truth, my goal for the channel, next year and the year after, is I'm trying to reach out to the younger grades also. I enjoy making content for AP Calculus, and, I'll keep making AP Calc videos, over time. But, now I'm starting to make, 5th grade videos, 6th grade, and so on. I'm trying to get to the... Yeah, so average rate of change, so at WOW 20, yeah, the big idea is this. Velocity is the rate of change of position, okay? So average velocity is average rate of change of position. So if this is the position function, that's the one we're finding the average rate of change of. So we just go forward with that here. So we have this, and then minus x of 0 is just 0 over 3 minus 0. Now this gives us negative 5 times 9 over 3, and then that gives us negative 15. All right, yeah, this one is very concept heavy because a lot of people are going to do 1 over b minus a integral a to b. The reason why you don't do that one here is because they're not asking for average position. Okay, they're asking for average velocity. All right, but there is a connection between those two formulas. Yeah, this formula, 1 over b minus a, this one, don't use it here. Okay, this is average value of f on AB. Very easy to mix up. Which of the following functions are continuous for all real numbers x? This one, I would just draw it out. So this one, cube root, so if I write it like this, y equals cube root of x squared, domain here is all real numbers. Okay, so this one is going to be continuous. It's going to look something like this. All right, I like to call this one the bird function, because if you're not the best artist like me, you probably draw your birds to look something like this. So this one is not, let me make that neater, not differentiable at x equals 0. because of that sharp turn. But it is continuous. Continuous, I always tell my in-person students, like the third grade definition is you could draw it in one motion. Okay, so this function, I could definitely draw it in one motion. So this is continuous. Which of the following functions are continuous for all real numbers? Definitely this one. E to the x, we should know what that looks like. It looks like this. That's definitely continuous and differentiable. But y equals tangent x is a problem because it has infinite vertical asymptotes. So it has infinite discontinuities going on forever. Okay, so this one, no. And you can even see like y equals tangent x is y equals sine x over cosine x. And cosine x equals 0. This has like infinite solutions. So there's like an infinite amount of times where tangent x is, you know, discontinuous, and it has an infinite discontinuity. All right, so 1 and 2 only. Choice D. All right, U substitution. So this one I would rename things, call this sine 2x over cosine 2x. And I would make U equal cosine 2x. So then du is negative sine 2x. I do the derivative of the outside, keep the inside the same, but then the derivative of the inside is 2. And then I tack on dx. Okay, so I like to solve for the leftovers. See how there's like a sine 2x dx? So I solve for sine 2x dx here. And I can multiply both sides by negative half and say negative half du is equal to sine 2x dx. So now substitution. I could say this equals integral of u on bottom and then negative 1/2 and then du. The negative 1/2 I could just bring out in front. And now this is negative half, natural log, absolute value u, plus c. So this is negative half, natural log, absolute value u is cosine 2x, and then plus c. So it looks like choice B. All right. Cool, cool. Related rates. Ooh. All right. So this one, yeah, related rates sometimes makes people sad. So this one here, we have our volume of a cone formula, and they tell us the radius and height are increasing at a constant rate of 1/2 centimeters per second. So this stuff, maybe I'll color code it like the orange here. They're telling us dr dt equals 1/2 centimeters per second, and dh dt, let me make that neater. So dh dt is 1/2 centimeters per second, and they want us to find here what is the, at what rate in cubic centimeters per second is volume increasing. Okay, so this one we're going to be deriving with respect to time. So we're going to go dv dt equals 1/3 pi is constant, so I leave it outside. And now I'm using product rule. uv prime is u prime v plus uv prime. Okay, so I'm treating r squared as u and h is equal to v. So u prime is 2r dr dt. With related rates, you derive with respect to time, so you always got to tack on that extra piece, unless your function was in terms of t, but usually it's not. So I have u prime times v plus, and now I have u is r squared times the derivative of h is dh dt. And now we just plug in. Okay, the constant, once again, I kept on the outside. So when the height is 9, so we have h equals 9 centimeters, and the radius is 6 centimeters. All right, so we plug in, and let's do this in a different color. So dv dt equals 1/3 pi. We plug in, we got 2 times 6. I'm not going to write the units, I'll just write it at the end. But we have 2 times 6 times dr dt is a half times h is equal to 9 plus r squared. R is equal to 6. So I get 36 times dh dt is a half. And now just simplify. We get 1/3 pi. 2 times a half cancels. 6 times 9 is 54. Plus half of 36 is 18. And now we got 1/3 pi times 72. And then 72 divided by 3 is 24. So 24 pi. Choice C is the answer. Cool. All right. Yeah, so at the end of these, like multiple choice, there's going to be unit 10, unit 9 and 10 stuff. Yeah, I would memorize. So at Edgar, memorize like obviously linear, quadratic, cubic, square roots, sine and cosine. You know, like, so basically like most, like basically any polynomial that isn't like insanely complicated. And then like exponential, logs, like those kind of functions, it's good to know. So exponents, logs, sine and cosine, even tangent inverse, it doesn't hurt to know. Like those are, it helps, especially when they ask you to like start finding volume and stuff, like, or area between curves. Like it helps to know that. All right, this one, really getting that unit 6 practice here. Unit 6 is 20% of the test, so I guess I could justify this. So here, antiderivative of sine 3x. So this one you could just kind of go, if you want to go straight forward with it, you can. So this would be negative 1/3 cosine 3x. If I have to check, I just derive. The derivative of cosine is negative sine. So negative negative would go back, and the derivative of the inside is 3, which would wipe out that. So that's how I know we're good here. And now we got negative 1/3 times cosine of 3 times pi over 3 minus cosine of 0. Okay, 3 over 3 cancels, and we get negative 1/3. Cosine pi is negative 1. We get minus 1 again. So we get negative 1/3 times negative 2 is 2/3. So we get this. Okay, so that's how. I believe I have an optimization question in here somewhere. Okay, so yeah, I've. If not, though, I could talk about optimization for sure. Optimization, I know, is like one of the worst topics in Calc AB. Even BC, it's like, you know, it's one of those questions that just tends to like really get people like, whoa, this is a lot. Okay, so f prime, here's a graph of f prime. Which of the following could be the graph of f? So sign charts are also good. Like if you get stuck on these, negative 1 to 1, I'm sorry, negative 1 and 1, those are the roots. And you can see f prime is positive because it's above the x-axis. Then it goes negative, and then it goes positive. So the behavior of f is increasing at first because f prime is positive, then decreasing, then increasing again. So we need a graph that goes up, down, up. See, up, down, up, but this goes down, up, down, so no. And this just goes up, this just goes down, so goodbye, goodbye. So now it's like, uh-oh, A or B. But notice the sign change here occurs at negative 1. So this means that we're going to have a local max at this location at negative 1, and we're going to have a local minimum by the first derivative test at x equals positive 1. So you see how here it's like, it's off because the local max is over here at like negative half, and the local min is off center here. But at negative 1, see how we have our local max, and at positive 1, our local min? Choice B is it. Okay, so nice question, concept heavy. All right, now this one, here we go, unit 8. The area of the region enclosed by these two graphs. So I'm going to draw out first the more complicated one, x to the third plus 8. So with this one, I just think of x to the third power like this, and then just know that it's shifted up 8. So like something like this. Okay, so here, that's going to be at y equals 8. And then we have y equals x plus 8 is a straight line like this. And this is not necessarily like drawn to scale, but it's going to be something like this. Okay, but they're saying in the first quadrant. So we're just talking about this piece. Now this one, it's debatable, like, like, how do I find the point of intersection? Some would just say, all right, just say like 0. You plug in 0, you get 0 plus 8, 0 plus 8 matches. You plug in 1, you get 1 plus 8, 1 plus 8. So if you could just kind of eyeball it, great. Otherwise, algebra, you just set x to the third plus 8 equal to x plus 8. And these wipe out. And you could get x to the third equals x, or x to the third minus x equals 0. Factor out x, and you get x times x squared minus 1 equals 0. And you get x equals 0. And this one gives you x equals plus or minus 1. So you see how, like, at minus 1 over here would be the other intersection point. But we don't really need that. We're just talking about quadrant 1, so we care about this piece. So now concept, the area of this overlapping region. I take this. I take one cross-section. The concept of Unit 8 is one cross-section tells you all you need to know about area and volume. So here, the vertical distance, just imagine I always teach it like this. 8 and 5 are 3 away. I could do 8 minus 5 equals 3, the top minus the bottom. So you see how in purple, in quadrant 1, the purple is above. That's the line y equals x plus 8. And then the pink, the cubic function over here is on bottom, y equals x to the third plus 8. So the vertical distance, I would just do x plus 8, but then minus x to the third plus 8. And let me section this off so we don't collide. And now this gives us x plus 8 minus x to the third minus 8. 8 minus 8 cancels, so this distance is just x minus x to the third, and the little horizontal distance is dx. So the area of one slice here, that little slice, the area is x minus x to the third dx. And for the whole area, I would integrate from 0 to 1. Okay, so then this tells us, I'll change colors here, that the area is anti-derive. You get 1/2 x squared minus 1/4 x to the fourth. And we evaluate from 0 to 1. So we get 1/2 minus 1/4 minus 0. Because when I plug in 1, I just get the coefficients. When I plug in 0, everything wipes out. And then 1/2 is 2/4. And 2/4 minus 1/4 is 1/4. So choice A, 34 is A. This is definitely calc. Yep, right now. I forgot chain rule. Wait, where did I forget chain rule? All right, let's... Oh, my bad. I should have thrown this question out. This doesn't belong. This is like just trig. Okay, but hey, why not review a little trig? So we have a sine function for one complete period. Which of the following is an equation? So the period is equal to 2. Okay, frequency is equal to 2 pi over the period. So the frequency is 2 pi divided by 2, or equal to pi. And in general, for sine, you have like y equals a sine bx plus c, where like this is the midline. Doesn't hurt to know a little pre-calculus for this. Frequency, amplitude. The amplitude is the distance to the midline. So see how the midline is here at 0? Okay, so we could say like our value c in this case. So c is equal to 0. The frequency, our b value, is equal to pi. But the amplitude is the distance from the midline to the max or min. So our amplitude is equal to 2. So then I just plug in. I get y equals 2 sine pi x plus 0, or just 2 sine pi x. 35 is D. Okay. Yeah, it's an old calc exam. They used to like really want to see that people know like other stuff. But I mean, it doesn't hurt to know a little trig. I wouldn't obsess over it though. All right, here we go. This is a good one. 36. So someone's like, oh, concepts. That was a great question before, because yeah, concepts are really big on the AP test. So for this one, we have f is continuous, is a continuous function defined for all real numbers x, and the max value of x is, I'm sorry, the max value of f of x is 5, and the min value of f of x is -7. These are official, indeed. Okay, so what are they saying here? And the minimum value is -7. Which of the following must be true? All right, so we have to try to draw this multiple ways to make some of them not true. We need the one that's like a must be true. All right, let me fix that. Okay. So here, like a few different ways we could draw this is we are limited. The max value is 5. So the max value is 5 and the minimum value is -7. So like, let's say I draw it like this. Like, I don't know, it has, whoops, I don't want to draw it like that. Like something like this. Like kind of like this. And let's say like, all right, it actually hits 5 and it hits -7. The max value of f of absolute value x. So what does that do to a function, f of absolute value x? Basically, it only allows us to look like the x values are now only greater than or equal to 0. Because like, let's say this happens at -1. If I did f of absolute value -1, this would give us f of 1. So you see how like it basically just like x's out this part of the graph. So the max value of this is 5. I could eliminate because if the maximum value occurs on the negative side of the x-axis, we have to eliminate this part of the graph here. Basically, like everything just gets mapped to this now. Okay, like it just basically turns this sort of into like an even function where like it's going to look, you know, something like this. Okay, like we're only allowed to work with whatever was on the positive side of the x-axis. Okay, so like that's the concept here. So Roman numeral 1 is out. The max, all right, so this is different. Absolute value outside, what does that do to a function? So if I get rid of the x's that were here, when you throw absolute value around the function, it takes the negative stuff and it flips it up. Okay, so it flips it up like this. And this one, let me actually draw it higher. If it went at a low point of -7, it's going to go to a high point of +7. So this one is true. If the minimum value is -7, then the maximum value of the absolute value of f of x is going to be +7. So that one's good, which eliminates this, and they all have 2. So it eliminates one of them. The minimum value, oh, here we go again. The minimum value of f of absolute value x is 0. That's not true. Because f of absolute value x, like let's say this is at 3. If I have f of, this is f of 3, which is -7, which is less than this. So goodbye to this. So 2 only. Hard question. Because like you got to draw and think. A lot of crazy stuff happening. All right, so something to change things up. And then back to concepts. So this is the limit as x goes to 0. Cosecant x is 1 over sine x. So I could write this. Now, if you just recognize this limit, then great. You could just say this is 1 and you're done. But let's say you don't recognize it. Like even the reciprocal still counts. You just derive top and bottom. Then you plug in. Okay, and you get this. So either way, choice D. All right, we're making good progress. Question 38. So I'm going to take a little water break. Let me check out the chat. 135 people here. Thank you all, for real. And if it's anybody new who wasn't here before, if you haven't subscribed yet and this is helping you, I would hope you would consider pressing that subscribe button. All right, this is always a very exciting time of year, like connecting with everybody. But yeah, I appreciate the support here, having everybody, you know, on here with me. So yeah, I was taking a quick water break here because I've been talking for like, you know, a few hours now, or actually, how long is this going now? Oh yeah, an hour and 40 minutes. So definitely need a second to have a water break. But let's see. How are we? Okay. Yeah, we're doing all right here. Let me see the chat. Oh, thank you. Everyone subscribe to this legend. I have ways to go. At Ryan. So hello, Ryan. If this is like last year, Ryan, I hope you're doing well. Yeah, that's another one of my favorite things too with doing these live streams is like when like the students from the past stop in to say hello. It's always nice to, like see like former students and stuff. So I do appreciate it. It's almost like the old students welcoming the new ones to their rite of passage to take this test. So, yeah, I'm glad you're all a part of this. This is like, we're all doing something great here. All right. So question 38, here we go. Something a little wacky. So if f is less than or equal to g for all real numbers x, graphically that means like this one is under and this one is over. Okay? They could like meet each other at some points, but like for the most part, like f we'll just say is under. So let's say like this is, I don't know, I'll say like that's f of x. And then, so f of x is in red. And then g of x I'll throw in pink is like, let's say something like this. All right, so here's g of x. And let's go through the Roman numerals. So is it true that f prime, like which one must be true? Is f prime always less than or equal to g? Well, just because f is under doesn't mean that they're always lining up with their rates of change. Like meaning, see how here, like f prime at this location, like let's say this is like at, I don't know, 10. F prime of 10 is greater than 0 because f is increasing here. But if I look here, let me actually line it up. Like here, g prime of 10, the way I drew it, is less than 0. So that contradicts this. All right, f prime is not necessarily always less than or equal to g prime. Just because the graph of g is, above. That doesn't mean that they're always going to be, let's say, increasing together and g is going to be increasing at a faster rate. So this is out. Is the concavity always going to line up? Not necessarily. See how here, same part of the graph, that g double prime of 10, the way I drew it, is less than 0, and f double prime of 10 is, yeah, maybe it's like just becoming concave. Let's say I go here, though. Let's say at like 9. Okay, so still g double prime of 9, less than 0. But f double prime of 9, the way I drew it, greater than 0. So this one's also false. So now it's either going to be like, 3 only or none. But this one is in fact true. The area from 0 to 1. If this one is always over, then the area from 0 to 1 is always going to be more or equal to for g. So see, like this is it for g, but for f, it's like this little space here. And it's because the pink curve is always above the red. So this one is going to be true. So choice C. All right. Awesome. And now we move on. All right, more first derivative test concepts. So yeah, this one is technique. This one is concepts coming up. So we'll take a look. All right, so 39. And we're making good progress here. Let me see. Where does this... This one ends... 50 something. But we're getting there. I got like 4 more sheets of paper to get through. All right, here we go. So f equals this. Which of the following is true? So increasing, decreasing, we're going to take a derivative. So call this u, v, and we will use the quotient rule. So just remember your quotient rule. It really helps to know these formulas. So f prime equals x times the derivative of natural log is 1 over x minus ln x times the derivative of x is 1 over x squared. X times 1 over x is just equal to 1. So I get f prime equals 1 minus ln x over x squared. Now they said domain x greater than 0. And that's because ln x is only defined for positive x's. Okay, so yeah, that brings us here. And I want to point out that x squared is greater than or equal to 0 for all x. Now, we don't have to worry about the denominator equaling 0 because x is, like, the domain is set to be greater than 0. So we're just going to target the numerator. F prime equals 0 when 1 minus ln x equals 0. And then from here, I could add ln x to both sides. Wait, sorry, the pen is freaking out a little bit. Let me get this. So here, what I could do is I could say 1 equals ln x. And then you just know that this is base e. And this will tell you like e to the first equals x. Okay. Or you just say natural log of e equals 1. So x is equal to e. And once you know x is equal to e, you make your sign chart for f prime. And let me actually start off here at 0. So everything greater than 0, I have something here at e. And what I could do, like if you're like, oh no, what do I plug in? You could plug in e to the 1/2, which is square root e. This is less than e. Okay, so I would plug in, not necessarily it's going to land over here, but like e to the 1/2. If you plug that into f prime, so now let me get rid of this stuff over here. If I plug that into f prime, I would have f prime of e to the 1/2 is equal to 1 minus natural log e to the 1/2 over radical e squared. Okay, which gives us the 1/2 could just go in front, and I get 1 minus 1/2. Natural log e is 1 over e, and that's 1/2 over e, which is positive. And then if I plug in something like, let's say over here, like e squared, I would get like 1 minus natural log of e squared over e squared squared, or e to the 4. And then that 2 would go in front. I'll get 1 minus 2 is negative 1, so this comes out negative. Okay, so this tells us now the behavior of f. F is increasing from 0 to e and decreasing from e to infinity. Or I could say f is decreasing for all x. F is decreasing for all x greater than e. Cool. Okay. Another live tomorrow. I think, tomorrow might be a nice day to do some FRQs. I feel like this is more just about like connecting with everybody. Like if you're all anxious, just being like, hey, it's going to be all right. I think you'll, do okay. Just, do what you can on Monday and whatnot. It's normal to be nervous if you are nervous. I think that just means you care. That never goes away. When you take a test, it just does not go away. Like the test anxiety, that little like nerves. But I mean, it goes away once you take the test. Like when you're taking the test, like if you just focus on the math in front of you, but the before, no. Oh, if you rewind, I did like a bunch of U-sub questions. I might have another one though in here somewhere. So f is continuous, and f is bounded between 2 and 4. So like here's 2, here's 4, and it's like between here and here. But they're asking what's the greatest possible value of the integral. If we want the integral to be as great as possible on 0, 2, then we should make f of x as maximum as possible. And if the maximum value we're allowed is equal to 4, then we could just say like f of x is equal to 4. And that's like the max value. So then here, the integral from 0 to 2, this is just a rectangle. 2 by 4 is 8. So 40 should be choice D. All right. Moving on. Oh, this is a nice question. Concept heavy. If the limit as x approaches a of f of x equals L, then which of the following must be true? The derivative exists. Well, not necessarily. If the limit exists, you could actually have a hole in the graph here, and this is still true. Okay, so we could have, like, let's say, like a removable discontinuity. And if you have a removable discontinuity, the limit exists, it's just not equal to the function. So if you're not continuous at a point, your derivative doesn't have to exist. We want the one that must be true. So this is out. F does not have to be continuous to have, if it has a limit, you don't necessarily have to be continuous there. And you don't have to be defined there as well. See how I put an open circle here? The function value equals L, not necessarily. That would only be if f is continuous, so none of the above. Okay, like having a limit at a location is kind of like the starting point. It's like, all right, and then from there you build up to continuity. And from there you build up to differentiability. So choice E. All right, let's see. More water. Can you use AI? Yeah, I wouldn't. I mean, AI is a very useful tool. I'm not going to pretend like it doesn't exist. But, do make sure that you... Yeah, this is going to get uploaded. Not to worry. This will stay on YouTube. As did my last year reviews. They're still up on YouTube. Okay, so here, just know this one. So the fundamental theorem of calculus. This is the name. The class is called AP Calculus, right? So we should know the fundamental theorem of calculus. So here, like basically when you derive an area function from, this is like, just representing some constant to x, the derivative and the integral cancel and just gives you f of x. So here, this is just 1 plus x squared under the square root. So choice C. So easy, it's difficult. Oh, you got a 98 on the mock? Like, that's really good. So, I don't know. You could just, like, hang out, I guess, and just kind of, like, pretend like it's like, almost like you're listening to music. Yeah, if you're, like, in the close to 100 out of 108 range, like, you're in a really strong spot to do well. Yeah, BC is coming soon. See, like, after... See, here it is. 46. Stay tuned. So, 45 and on is BC only. So, we're getting close to the end of the AB stuff. All right. Equation of a tangent line to this at its point of inflection. So there's a lot happening here. We got to just know the difference between y, y prime, and y double. Oh, you could say derive as a verb, right? Is that a verb? I hope it is. Derive and anti-derive. Let's see. Is that a word? Yeah, like derive this. I feel like that's the verb. Now I'm curious. Great question. Is derive a verb in calculus? I feel like I just heard it somewhere. And it's just... Yeah, derive. You could say derive. Don't say derivate, Yeah, deriving. But I don't know. I'll look into that. Tomato, I guess. But sure, that kind of stuff is big. Because if you say the wrong thing, communication and notation is 20% of the free response. So if you communicate something wrong, it's like, oh no, there goes my 108. Okay. So point of inflection, I got to find two derivatives. So y prime gives me this, and then y double gives me this one. So I set my second derivative equal to 0, which tells us we are going to have a point of inflection at x equals -1 because our second derivative changes signs at -1. See if like I plug in 0, I get 6, which is positive. If I plug in -2, I get a negative here. So the sign change, we have a point of inflection at x equals -1. Okay, I could say y. Yeah, y has a point of inflection at x equals -1. Okay, so like this equation. But they want us to write the equation of a tangent line there. So what we need to do is we need to plug in x equals -1 to the original equation first. So y equals -1 to the third plus 3 times -1 squared plus 2. That gives us -1 plus 3 plus 2, which is 4, which tells us -1, 4. This is our point. And then our slope is going to come from y prime at x equals -1. So now we plug in here 3 times -1 squared plus 6 times -1 gives us 3 minus 6 is -3. And now just write the equation of a line. I like this formula, the point slope form equation. So that's the one I'm going to use. Y minus, this is x1, y1. So y minus 4 equals negative 3. X minus minus 1 becomes x plus 1. Y minus 4 is negative 3x minus 3. Then just go plus 4 on both sides. Okay, negative 3x plus 1, choice B. All right. So the average value of f on the closed interval 0, 2. So here, this is just knowing the formula 1 over b minus a, integral a to b of the function. Oh, this is a nice close to the AB stuff. So this one, we could do a U substitution. So someone asked about U substitution a moment ago. So this is your time. Okay, so this. So say U equals x to the third plus 1. Du is 3x squared dx. And I would actually just solve for x squared dx. Multiply both sides by a third. You get 1/3 du, or divide both sides by 3, and you get this here. And then I would find new limits. So my new limits, these are my old x limits. This is like x equals 2, x equals 0. So my new u limits are going to be 2 to the third plus 1, which is 9. And then I plug in 0, and I get 0 to the third plus 1 is equal to 1. So my new integral is integral of 1/2, and then my new limits are 1 and 9. And then x squared dx, see like this piece here, the x squared dx, that I could replace with 1/3 du. And then we have the square root of u. Okay, so this makes 1/6 integral 1 to 9 u to the 1/2 du. And then this is 1/6 u to the 3/2, and then the 2/3 goes in front from 1 to 9. And now this becomes 2 over 18 is 1/9. So this is 1/9. And then we've got u to the 3/2, I'll write over here, is the same thing as the square root of u to the third power. So I could go square root of 9 to the third power minus square root of 1 to the third power. And now this works out to, let's see, square root of 9 is 3 to the third is 27. 27 minus 1 is 26. So this makes 26 over 9. And 26 over 9 matches up with choice A. All right, cool. So a particle moves in the xy plane. So here we go, polar. I'm not polar, I'm sorry, parametric. Acceleration vector. So for these, let's see, a particle moves so that anytime t its coordinates. So we have the position here. So we have position. So the position function, I'll write it vector valued, is like t squared minus 1, comma, whoops, this is possessed. Let's fix this. All right, t squared minus 1, and then t to the fourth minus 2t to the third. So velocity, we just derive. Oh, differentiate. How about that? We shall differentiate this. Okay. All right, that one is just for, yeah, keeping things, sure, I could go with differentiate. Why not? We'll say that. And then acceleration is 2 comma 12t squared minus 12t. At t equals 1, two comma 12 minus 12. See, I plug in 1, I could just get 12 minus 12. So the acceleration vector is 2 comma 0. Choice D. Let's hope. Because I am starting to get a little tired. So I don't want to start saying silly things. Yeah, we're good. All right. Ooh, Unit 10. Oh, this is like one of the nicer Unit 10 questions. So this we're looking for f prime of x. But you see how the only x is the x to the 2n minus 1. So we just power rule this. So we got the series from n equals 1 to infinity. You could, find the antiderivative and derivative of a power series. So I just do the power rule. 2n minus 1 comes down, times x to the 2n minus 1, which is 2n minus 2. And then these wipe out. So it's just negative 1 to the n plus 1 times x to the 2n minus 2, series from 1 to infinity. So choice A. Yeah, that's a nice one. See, not all of Unit 10 is bad. Like, that's the point of this. Like, sometimes they'll just throw, like, a nice Unit 10 question your way, and that's just, like, the stuff you got to do to be okay with it. Ooh, partial fractions. All right. This is, just know, this is 95% algebra. Okay, so what I'm doing is like 1 over x minus 1, x plus 2. I say is like a over x minus 1 plus b over x plus 2. And then the algebra that I do, but like I basically don't show, but for the review I'll show it, is I do this part in my head, but let me just see. Can I, oh, I can't duplicate that. All right. So this goes on in my head, but I go x plus 2 over x plus 2, and then x minus 1 over x minus 1. And then all the denominators just wipe out. And you get 1 equals a times x plus 2 plus b times x minus 1. So what I basically do is I just like multiply, I have like 1 equals a times the other denominator plus b times the other denominator. And then I plug in test values. So I want to plug in x values that would wipe out the factors. So I'm going to plug in x equals negative 2, and I get 1 equals a times 0 plus b times negative 2 minus 1 is negative 3. So this wipes out. 1 equals negative 3b, which tells us b equals negative third. And then I plug in, let's say, x equals 1. And that gives us 1 equals a times 1 plus 2 plus b times 0, which gives us 1 equals 3a, so a equals a third. Now how this helps us is we're going to replace a with 1/3 and b with negative 1/3, and we can rewrite this integral now as 1/3 over x minus 1, and then plus negative 1/3, or I could say minus 1/3 over x plus 2. So the whole point of partial fraction decomposition is to break this down into easier fractions. Because now it's just 1/3 ln absolute value x minus 1 minus 1/3 ln absolute value x plus 2 plus c. And then we look and we're like, oh no, my answer is not there. The reason why the answer is not there is because we have to know log properties. So you have to know like ln a minus ln b is ln of a over b. So here I could just like, take out the 1/3, factor it, and then I have ln of this minus ln of this. So it becomes ln absolute value x minus 1 over x plus 2 plus c. And then choice A is our answer. Okay. Cool. All right. So moving on. All right, this one, spider sense. That's what I tell my students. You need a spider sense. So which series are convergent? You need to know this one. So converges when p is greater than 1. Diverges, so a p series diverges when p is less than or equal to 1. So this one I'm like, ooh, the power equals 2, greater than 1. If I do a sum of, well, we have the squares in the denominator, the power 2 is greater than 1, so this series will converge. Okay, this one is the harmonic series, and that diverges. Okay, that is a classic series. This series diverges. You could also go p series here and say p equals 1, which is less than or equal to 1. Okay, so therefore diverges, but that's the idea. And then alternating series. Okay, so an alternating series, if I have something like this, like let's say negative 1 to the n times, b sub n, and then like b sub n is something here. Let's say like this part is greater than or equal to 0. And what we have, if this series, the terms decrease in magnitude to 0, then the series will converge by the alternating series test. Okay. I mean, usually like on the AP test, like they're basically always giving you like B sub n is like strictly like positive. Like the -1 to the n times the B sub n, it's an alternating series because you're not going to use the alternating series test for convergence unless you have an alternating series. So like this is like really what you're dealing with. The terms decrease in magnitude to 0. If that occurs, that means like that the series will converge by the alternating series test. Okay, which I'm just going to abbreviate like this. And not that many times. All right, by the alternating series test. So here, when I look, I'm like, all right, this test could be applied here for this series. We have an alternating series, and the terms are decreasing in magnitude. See, it's like 1/3, 1/9, and it's decreasing at an exponential rate. I could also use the geometric series test here. See how this is also a geometric series. And for geometric, if you have a series in the form of r to the n, if absolute value r is less than 1, your series converges. All right, which basically means if r is between -1 and 1, your series converges. And if it's not, if it's greater than or equal to 1r, series diverges. So here, see how r equals -1/3? And absolute value of -1/3 is definitely less than 1, so this series converges. So you could show it converges by alternating series test or geometric series test. So 1 and 3, choice C. All right. Yeah, it's BC only right now. So this is like, yeah, integration by parts, but like a little wacky. Okay, so this one, this is, let's say, u dv, but remember, integral of u dv equals uv minus integral of v du. So here I would say u equals f of x, dv equals sine x dx, du is f prime of x dx, and the antiderivative of sine is negative cosine. Plus c, but we don't write that till the end. So integral f of x sine x dx equals, I have f of x times negative cosine x. You see how that gives me the first term here? So I have negative, and I have f of x cosine x. But then I have minus the antiderivative of, I'm doing a negative times a positive. So a negative times a positive works out negative, so minus minus is going to go plus. And then I have f prime of x times cosine x. And then dx. Okay, so here it might not seem like we accomplished anything, but if you look, 3x squared is the piece that corresponds to f prime. See how everything else, like the cosine x dx is here? Even like this, the negative f of x cosine x is here. So that means, in this case, that f prime of x is equal to the yellow here, 3x squared. So if we want to know what f of x could be, just anti-derive this, or anti-differentiate. Derivative of 3x squared, 3x to the third over 3, so we get x to the third plus c, which is choice B. Okay? Cool. How are we doing here? We're almost up to, wow, we're getting there. Polar area. Exciting. All right, let's see. Yeah, this is like the old school kind of polar area questions where they used to torture students. You'll see what I mean in a minute. Because like, they don't provide a graph, so you got to like kind of know how to graph these by hand. All right. Let's just see. How much more we got? I think we got, 52. All right, we're getting there. Okay, so the area of the region enclosed by the polar curve r equals sine 2 theta. So for this, some polar concepts. Theta and r. For a rose curve, or just polar in general, what I like to do, if we're between 0 and pi over 2, whatever this thing is here, like the 2 theta, I like to, I'm trying to think out loud. What's like the nicest way to do this? All right. Because I got to remember my thought process. Like this is like the 1985 way of doing things. So I think like, all right, sine, it's good to know like when is sine equal to 0? Sine of 0 equals 0. So I could say 2 theta equals 0, which gives me theta equals 0. But I could also say 2 theta equals pi is the next time. So then theta would equal pi over 2. So that's why they're kind of doing that here, because that's going to give us a full pedal. Okay, so for this, like 0 and then pi over 2 are going to give us the 2 roots like this. But if we were to check out, like let's say pi over 4. If I plug in pi over 4, I get sine of 2 times pi over 4, which gives me sine of pi over 2, which is 1. So how this is working here is we're in quadrant 1. When we're at theta equals 0, this is theta equals 0. And then theta equals pi over 4 would be this way. And then theta equals, if I have pi over 2, is going this way. So I'm going from like r equals 0 to r equals 1. So it's like opening like this. And then r decreases from 1 to 0, so it swings back to give us the pedal. Okay, so we're finding the area of this pedal. If I had to do more, like let's say I had to find more of these points, you know, I would keep counting by pi over 4 here, and that would start to graph the rest of this thing. Okay, so yeah, that's the idea behind this. So now, what is the area of this? What we could do is polar area, integral theta 1, theta 2, 1/2 r squared d theta. So I just go 1/2 integral 0 to pi over 2. And I go r squared. So I'm going to have sine squared 2 theta d theta. So in 1985, they were like, hey, you should know for the 1985 test that sine squared is equal to 1/2 times 1 minus cosine 2x like this. Okay, so that's something like in 1985 that they were like, ha ha ha, you should know this. And then they took it away because it was making too many people sad. So 1/2, but why not like practice the old way? So 1/2 times 1 minus, but the idea is, see, we call this the argument. The part that's inside the trig function gets doubled. Okay, so if it's originally 2 theta, it's going to be 1 minus cosine of, I double 2 theta to get 4 theta. Okay, so that's going to bring me here. And then for the rest, it's just a matter of like closing this out correctly. So now these two, 1/2 times 1/2 is going to make 1/4. And now antiderivative of 1 is theta, minus the antiderivative of cosine 4 theta. We're going to have 1/4 and then sine 4 theta. Okay, and this is being evaluated from 0 to pi over 2. So now we just plug in, this is 1/4. We have pi over 2 minus 1/4 sine of, if I do 4 times pi over 2, gives us 2 pi. So this piece just wipes out. Okay, and then minus, so we still have that 1/4 in front of all this. When I plug in 0, everything wipes out. So it's really just 1/4 times pi over 2, which is just pi over 8. So this one should be choice D. All right. Oh, someone benches 250 pounds? Oof. That's pretty good. That's what I curl, but that's not a bad bench. Pretty good for high school. All right. So moving on here. Hate trig identities. Yeah, that's why I wrote 1985. The only ones like you got to know for the AP test, like if it is going to show up, is like this classic one. Like this one is like fair. That's the only one I would say that's fair. No, the newer ones, it's like, way. The newer one is like they got rid of that. Like the 1985 formula, like this is outdated. Like when I took Calc 2 in college, like they made me do that. And then they show mercy now. All right, interval of convergence is good to know. So it's MCQ. So I'll show you like kind of like the shortcut here. So the center is the X value that makes the power series go to 0. Okay, so here I'm like, all right, the center is at 1. And if the center is at 1, that means this answer choice is out because this would be a center of 0. See how like from -1 to 1, 0 would be in the center. So this is out, this is out. So it's like C, D, and E. So this is like the multiple choice tricks. How do you get there without actually knowing the ratio test? So centered at 1, and now the $1 million question is, does my series converge at 0 or 2? So at x equals 0, I would just plug in. Because I would have to do this anyway if I use the ratio test. So x equals 0, I would have 0 minus 1. See, if I plug in 0, I get 0 minus 1 is -1 to the n over n. And this is an alternating series. And this series converges by the alternating series test because the terms are going to decrease in magnitude to 0. It just helps to know that, like to recognize certain series. They show up so much. But if you don't know that, like you could always expand it. -1 to the first is -1 over 1. And then plus, you'd have 1 over 2 next. If you plug in 2, -1 squared is 1 over 2. And then minus a third plus a fourth. So you see how the terms are. Terms decrease in magnitude to 0. Therefore, the series converges by the alternating series test. Okay, so convergence at 0 means this answer choice is out because this says like no convergence at 0. So it's D or E. But now if we plug in 2, the other endpoint, so we have convergence here at 0, but at 2, we would have, let me erase this. We would have 2 minus 1 to the n instead. So that would give us sigma 1 to the n, which is just 1 over n. And this is the harmonic series, which we said before, this diverges. Okay, let me make that neater. That's pretty terrible. Diverges. Okay, so no convergence at 2, which means the interval of convergence is going to be 0 to 2, including 0, but not including 2. So choice D. All right. The math you got to know, though, for the free response, you can't just play guess and check in the free response. Like they're going to be like, do the ratio test. So you actually got to know how to do the ratio test. But in the multiple choice, it's like anything goes. So that's like honestly what I would do because I don't feel like doing the ratio test unless they tell me to. Okay, so if I had to do the ratio test, remember you're going limit n goes to infinity of this. Okay, and let's say this equals L. L less than 1 implies series converges. And not only does it converge, it converges absolutely. Okay, if L greater than 1, then series diverges. And L equals 1 is inconclusive, which means we never get those seconds back in life for doing the wrong test. Okay, so now I'll actually do the ratio test. And I'm just going to erase this stuff from before. Okay, a little bit more. Get this out of here. Okay, I hope it all goes away. Okay, that should do it. All right. So now I'm going to do the ratio test. And this is like our A sub n. So A sub n plus 1 would be x minus 1 to the n plus 1 over n plus 1. So now I'm doing the limit as n goes to infinity, absolute value. A sub n plus 1 is this. But now when you divide by a sub n, dividing by a fraction, you really just multiply by the reciprocal. Okay, so I could go times n over x minus 1 to the n. Close this. And now x minus 1 to the n plus 1 over x minus 1 to the n, this wipes out and leaves us with a power of 1. So now this is the limit as n goes to infinity of absolute value x minus 1 times, I could say absolute value of n over n plus 1 separate like this. But n is going to infinity, so n over n plus 1 is going to be positive. So the absolute value could just disappear. But now unit 1 skills. N over n, that limit goes to 1 as n goes to infinity. The limit as n goes to infinity doesn't affect the x part. It affects the stuff with the variable n. So now this just becomes this. But then what you do is, once you find the limit, you set it to be less than 1. We say, all right, now this, absolute value x less than 1, implies that the inside is between -1 and 1. And then you see when you go plus 1 like this, it basically brings you to this step. Like the interior. This is not the interval of convergence. This is the interior of the interval of convergence. Okay, then we still have to check the endpoints like we did before. So this is sort of like, a waste of time. Okay, cool. So either way though, choice D. All right, 52. Oh, last question. Here we go. Yeah, I'm like, oh wait, this zoomed in. Yeah, this is gonna be probably my last one. 2 hours and 20 minutes is definitely. I'm starting to feel the burn a bit. All right, tomorrow I'll do some more questions. Wait, on question 38. Let's see. 3, would it be false because if the integrals are negative? Yeah, but if the integrals are both negative, so let's talk about that. So let's say this is like positive x, positive y, like here's 0. There's the origin. If like this whole stuff was happening over here, it still like works out because area from 0 to 1. See how like this one is like it's negative, but this one down here is like more negative. So more negative means it's less. Okay, if like this is f, let's color code it again. Okay, so if like the absolute value of the negative number is greater, then the negative number is less. It's like, owing money. Would you rather owe $10 or $10,000? It's like, so like this is like owing more money if you're f. So that's why it still works out for 3. All right, good question though. That's why that was I like that multiple choice question because it's a little confusing. Like it's like you really got to think deep. All right, last one. So a Taylor series, if you're centered at 0, just know that in general, like this is the formula to know. So this is the expanded. So it's really good to know this formula. Okay, so this in general is good. But what else is good to know is like in terms of C, like, this is the Maclaurin formula. The general Taylor formula is good to know for the AP test. So like this one is good. Like when it's centered somewhere else, then this is the variation. All right, but this one, there's actually like a sort of a fast way to do this. Okay, plus ... And this goes on. For this one, though, the fastest way, in my opinion, is to just 3 formulas you should have memorized for Maclaurin. E to the x, sine x, cosine x. So e to the x, I know is this. I could use these formulas to build it from scratch. Sorry, my mouse is starting to freak out. I guess it's the... so this one is good to know. All right, so then when they're talking about e to the 3x, it's just algebra skills. You're just like, all right, 1 plus 3x plus 3x squared over 2 factorial plus 3x in parentheses to the third over 3 factorial plus dot, dot, dot. So what is the coefficient of the x to the third term? I'm targeting this piece here and just this. So I expand that, and I'm like, all right, that's 3 to the third x to the third over 3 times 2 times 1, which is 27x to the third over 6. Divide top and bottom by 3, and you get 9x to the third over 2. So 9 halves. That one should be choice E. And it is. And that's it. All right, so have those memorized. Okay, 2.5 hours just about together. So that is going to wrap things up for the Saturday night live stream. All right. Seeing the support that we got. Oh, thank you so much for the tip. I appreciate that so much. So yeah, thank you. But I'm gonna do my best to throw together some nice FRQs for tomorrow. So yeah, I will be back. And but if in the meantime you want to watch more stuff, my live streams from last year, I did put a lot of time into putting those together. They are pretty good. And yeah, just do what you have to do. I have my AP Calc review playlist like has a lot of good stuff in there. It has like the unit practice test if you want to practice unit stuff. But yeah. Okay. So have a good night, everybody. Thanks for stopping by. Happy studying.